In this video, I'm going to be discussing example 8.10 from the free online introductory statistics textbook, which you can download via this link. And I'm going to be using Microsoft Excel as my calculator. So let's start by reading through the example. Suppose that a market research firm is hired to estimate the percentage of adults living in a large city who have cell phones. So they go out and they randomly sample 500 people. So 500 people are surveyed, 421 say yes. Okay, so 421 say yes, must be 79 said no, right? That's just the leftover of from 500. Okay, we want to construct the 95% confidence interval for the true population proportion of residents who have cell phones. Okay, so what's going on here? We have a sample proportion, p hat, right? So sample proportion is the 421 divided by 500. The proportion of people that said yes. Okay, we have that. What we don't know is what is the population proportion p. We don't know the population proportion, right? So what we want to do is we want to construct an interval, right, around p hat. So here's p hat, and we want to construct some sort of buffer zone around p hat. And we'll have like a lower limit and an upper limit around p hat. Lower limit and upper limit. And we want to be 95% confident that P, the population proportion, is somewhere inside of this interval. Okay, so that's the big picture idea of what we're trying to do. Okay, so notice that this is a binomial distribution in the sense that, remember, binomial is for data that's yes, no. There's two answers someone can give. So yes, no, or smoke, not smoke, there's just girl, boy. There's just two choices, right? So that's binomial type data. This is a binomial distribution. Okay, but to construct this confidence interval, I'm actually going to use a normal distribution. Okay, so to find this margin of error, this buffer zone around p hat, I'm going to use a normal distribution. Well, hold on a second. Binomial distribution is not the same thing as normal distribution. How are you allowed to do that? Well, I'm going to basically, when the binomial distribution, when you have a large enough sample size, the distribution of your proportion p hat, it approximates the normal distribution. Okay? As long as, one thing, you need a large enough sample size. Okay, and what does that mean? That means the number of people that said yes needs to be more than 5. And the number of people that said no needs to be more than 5, right? So it's not that large of an assumption. You might see that written as p hat times n needs to be larger than 5, and q hat times n needs to be larger than 5, okay? And you can test that assumption. In general, unless you have a very rare event or a very small sample size, that assumption is always going to be met. Okay, so the number of people who say yes needs to be more than 5. The number of people that say no needs to be more than 5. Okay, once you've checked off that assumption, you're good to move forward. Let's use the normal distribution to find our margin of error around p hat. Okay, so let me go ahead and go to Excel. And let me type in p hat. And type in equals 421 divided by 500. Okay, I'm also going to find q hat. What is q hat? It's the complement of p hat. So it's always going to be, let me type in equals 1 minus, and then whatever p hat is. So I'll just press that cell. Press enter. Okay. So I'm go ahead and ready to figure out E, the margin of error. So I'm going to use confidence dot norm. Like I said, I'm using the normal distribution. All right. So what is alpha? Alpha, let me go back over here. Alpha is always 1 minus your confidence level. Our confidence level is 0.95. So 1 minus 0.95 is 0.05. Okay, so we got that from right there. 95% confident. So alpha is 1 minus 0.95, which is 0.05. Let me write that down. So when I type, first thing I'm going to type in is 0.05. Okay, let me move this over. And then I'll type a comma. The next thing I need to know is standard deviation. All right, standard deviation for the binomial distribution equals SQRT, and I'm going to open parentheses, the square root of P, okay, times Q hat, okay. I can't press that because my cursor is blocking it. So I'll write B2. You see how Q hat is sitting there in B2. So B1, which is P hat, times B2, which is Q hat. Close those parentheses. Okay, so that's the standard deviation. It's the square root of P hat times Q hat. Next, so put a comma. Next, I need the size. Size is sample size. How many people were surveyed? 500. Okay, close parentheses and press enter. There we go. There's our margin of error, 0.032. I'll round it, 0.032. 0.032. So now, to find my lower and upper limit, I basically need to subtract off the margin of error and add on the margin of error to our estimate P hat. So let me go back. My lower limit is going to be equal to P hat minus B, looks like B3. So P hat minus the margin of error is our lower limit, 0.81. Our upper limit equals P hat plus the margin of error. Press enter. 0.87. So 0.81 to 0.87. So we are 95% confident that the proportion of adults in the city that own a cell phone is between 0.81 and 0.87.